central angle. Okay, and your central angle is an angle whose vertex is the center of the circle. Okay, so just think about an angle. We've been dealing with angles a lot in this course. Remember, your vertex is the corner where the actual degree is occurring. So if I can make an angle where the vertex is the center of the circle, we call that a central angle. Okay, so in this diagram off to the right here, let's create a central angle. So eyeball where you think the center of the circle is and put a dot there. And then draw a radius from that center out to the side. And then draw another radius to create an angle there. So that is your central angle. Okay. So let's label it A for an endpoint and B, and then we'll put P in the middle for the center. So angle APB is my central angle. Now, does everybody see the two arcs that now are created? I've got the arc that's inside or in between A and B, which I'm going to highlight here in green. And that is what we call the minor arc. And the reason why it's a minor arc is because it is less than 180 degrees. So any arc that is less than 180 degrees, we consider that a minor arc. Okay? Any guesses on what you think the major arc would be? Above. So the rest of the circle, all the way around, would be my major arc. Which means that it has to be more than 180 degrees. Okay, so we've got minor arcs, major arcs. When I go to name those arcs, my minor arc, I would just put the two letters that are the endpoints of it and then put a little arc above it. So you see over there where I put arc AB. So if you're asked to name an arc, just like you would name an angle or a line segment, you would use its two endpoints and call it arc AB. If you were to name a major arc, you're going to need to have 3 points. So let's add a third point of C over here. So if I want to name the purple arc, or pink, whatever color you guys see, that would be arc A going through C, ending at B. So arc A, C, B. So major arcs will always have 3 letters, okay, because they're going to tell you which direction you need to go in. If you only see 2 letters, go the shortest distance between those 2 letters. So if I was told, look at arc AB, I'm going to go shortest distance. Okay, so what's a semicircle? Question? It would still be the same name.
Okay.
Yep. So it's just telling you, like giving you an idea of direction of where you should be going. Okay. Semicircle is what? Half the circle, right? So that means that your semicircle would be an arc. No, I do not want my upgrade reminder. It would be an arc with endpoints. So an arc with endpoints. Molly, quiet please. An arc with endpoints that are the endpoints of a diameter. So an arc with endpoints that are the endpoints of a diameter. And that's going to be the easiest way to decide whether your arc is a semicircle. Are its endpoints the endpoints of the diameter? Because a diameter splits a circle in half. It cuts right through the center. So if your arc has endpoints on the endpoints of the diameter, then it's going to be a semicircle. Okay? All right, so now let's talk about the relationship between the measures of minor and major arcs. So for our first one, we're going to talk about minors. So the measure of a minor arc is defined to be the measure of its central angle. So let's make an angle. Yeah, let's make a 90-degree angle. Why not? Let's make a central angle that looks like it's a 90-degree angle. Put A and B on your endpoints. Put point P back in the middle. And I'm going to put 90 degrees in there. So if my central angle is 90 degrees, then what this is telling me is that the arc itself would also be 90 degrees. So how do we write that notation-wise? Well, remember we use a lowercase m to stand for the measure of the angle or the measure of something. Here I'm going to do the measure of arc AB is equal to 90 degrees. And it works both ways. If my arc was 90, then I know that my angle is 90. If my angle is 90, then my arc is 90, and vice versa. Okay? So in our second option, talking about your major arcs, bring that right angle back. So 90 degrees, A, B, P. Just recreate that in the second circle. Now add a third point C somewhere off to the left. How many degrees would it be for arc ACB? Yes. And how do we get that? Right. So I'm finding the difference between 360 and its associated minor arc. So if this is 90, what's left over for the rest of the circle? Well, 360 minus 90, which is 270 degrees. Okay? So, can you determine whether something is minor, major, and a semicircle? Hopefully. Can you determine its measure of the arc, given a central angle? Hopefully. Let's see if you can do that. Flip onto the back. All right. What is the measure of arc DB? 135. Does everybody see why it's 135? So DB is here. Its central angle is 135, so its arc is going to be 135. Okay, what about DAB? So that means I'm going to start at D, loop through A, end at B. It's everything but what? 135. So how would I find that? Yeah, so 360 minus 135, which is 225. All right. Now let's find ADB. So start at A, go through D, end at B. Max, oh, I thought you were signing out. I was going to say, is your phone up there? That's going to be 180. Good. Why do I know it's 180? Because its endpoints A and B are on the diameter, so it's half a circle. Okay? All right. Next theorem, or this is a postulate actually, just like we had segment addition, just like we had angle addition, we have arc addition, which just tells us that we can add arcs together. So fill in the blank. It says the measure of an arc formed by two congruent arcs is the sum of the measure of the two arcs. So arc ABC would be the sum of this arc plus this arc. It's not very complicated. I don't even know if you need the picture on it for your notes. I'm sure you can figure that out. So now what's going to happen, and for some reason this diagram did not print out. I'm telling you, ever since I uploaded the new software for my Mac, things have been getting wonky. So you're going to have to recreate this diagram for the next example. Is everybody good? All right, so make a circle off to the right. Put a dot in the center. Throw in those central angles. I'll give you a second to get that copied down. Got this time? All right, seems like most of you guys are done. So let's see if we can figure this out. A, what's the measure of arc TQ? 120, perfect. 120 degrees. Did everybody see that? Central angle's 120, so the arc's 120. Next, QRT, so that means I'm going to start at Q. I have to go to R first, and then end at T would be everything but 120, so I would do 360 minus 120, which is 240 degrees. Everybody see that one? Okay. Now let's find Q to S. So now I'm going to go the shortest distance to Q to S. Oh, I have some unknown information here. So we've got multiple ways we could do this. Who thinks they know how to do that? Lily.
Add them all up and subtract them by 360.
To get this? Okay, so we could do that. So 80 plus 120 is 200. 200 plus 60 is 260. Subtract that from 360 tells me that this angle down here is 100 degrees. So from Q to S would be 160. Good. Another way we could have done it is I could have just done 360 minus 120 minus 80, which would have been 360 minus 200, which would have gotten me to 160 also, right? Okay, T to S, what's that? 80, good. Now we have TQR, so start at T, go through Q, end at R would be how many degrees? (180), half a circle. And then RST is the same, 180. All right, so we did half this problem. Now let's go ahead and identify them as major, minor, or semi. TQ, major, minor, or semi. Minor, less than 180. QRT, major, good. So major. QS, minor. TS, minor, right? It's only 80. And then the last two are semicircles. Good. Yeah.
How do you know from QS to go to which side?
You always go to the shortest length if you're only given two.
Oh, yeah.
So if I'm going just Q to S, it's quicker to go this route than that route. So if you only have two letters, it needs to be minor. So that means you have to have it be less than 180 degrees. Okay? All right. One more theorem for this chapter, which talks about congruent circles and arcs. So two circles are congruent circles if they have the same measure, which makes sense. If they have the same radii, so if one circle has a radius of 5 inches and the other circle has a radius of 5 inches, they're going to be congruent. Two arcs are congruent arcs if they have the same measure. So if they have the same central angle and the arcs are of the same circle or congruent circles. So if we look at these last three examples, things I need to, one, identify, are these two central angles in the same circle? Yes. So, would arc AB be congruent to arc DC? Why? They both have a central angle that's the same. They're in the same circle. So I'm going to say yes. Arc AB is congruent to arc DC. Okay. If we look at the second scenario, now we're not in the same circle, but are these circles congruent? Yes, because they both have congruent radii. Do they have the same central angle? So is arc PQ congruent to SR? Yes. So yes, PQ is congruent to RS. And then the last one, do I have congruent circles? No, definitely not. This circle definitely looks smaller than that circle, doesn't it? So I would say no. Not congruent. Okay, so questions with any of that?